Today is going to be the first day of Big Idea 8 Standard 2. Topic for today is collision theory. So before we get into collision theory, we need to understand what happens during a chemical reaction. So a chemical reaction is a process where one or more substances are changed due to a rearrangement of atoms. So here I have a reaction. Diatomic hydrogen plus chlorine makes 2 moles of HCl. So in order for this reaction to occur, we need to rearrange atoms. So what happens is the bonds between the reactants have to break. So I have a bond here between my 2 hydrogens since it's H2. I also have a bond here between my 2 chlorine atoms because it is Cl2. Well, in order to make HCl, hydrogen needs to bond with chlorine. So that means that these bonds must break. Next, after the bond of the reactants break, the atoms have to rearrange. So if I want to make HCl, this hydrogen needs to rearrange to get next to this chlorine. So the second thing that happens is that atoms rearrange. Once the atoms rearrange, we now need to form new bonds. So during a chemical reaction, the bonds between our reactants break, then our atoms rearrange. Once our atoms are rearranged, we're going to form new bonds between the products. Well, this can only occur if the reactants collide with one another. So if hydrogen never meets up with chlorine, it can't form HCl. So that brings us to collision theory. The rate of reaction, which just tells us how quickly a reaction occurs, depends on how often particles collide and with how much energy. So there are 2 parts to collision theory. First, molecules must collide with enough energy to reach the activation energy. So you should remember activation energy from last unit. This is my activation energy. How much energy do we have to put in for the reaction to occur? Remember, activation energy is the minimum energy required for a reaction to occur. So if 2 molecules collide, but they don't collide with enough energy, that reaction is not going to occur. The analogy that I like to always use for this is, let's pretend this was a hill. So here we have the hill, and let's say we have a golf ball. And we want to hit that golf ball up and over the hill. So we're going to hit the golf ball. And let's say you only hit it with a little bit of energy. Well, what's going to happen is that golf ball is going to roll back down. In order to get the golf ball up and over the hill, you need to hit it with enough energy to get to that top of the hill, and then it can roll down to the other side. So our chemical reactions kind of work the same way. If molecules collide, but they don't collide with enough energy, it's like that golf ball rolling back down the hill. They need to collide with enough energy in order for the reaction to be successful. Next, molecules must collide in the correct orientation or alignment. So let's say I had this reaction A plus BC. So let's say this is A, B, and C. So if A collides with B, we can form AB. So this collision would be successful because the molecules are arranged in the proper orientation. Well, now let's say we had A, but our molecule BC was in a different orientation. And now our molecules were to collide. Well, I can't form product AB if A doesn't collide with B. So this would be an unsuccessful collision. A good analogy for this orientation factor is to think about trying to put a cap on your pen. I'm a very good artist, as you can tell. So it needs to be properly aligned in order for your pen cap to go onto your pen. Let's say you flipped the cap upside down. So no matter how hard you tried, that pen cap is not going to go onto the pen because it's not in the proper orientation. So same thing with our chemical reactions. They need to be properly aligned in order to have a successful collision. In our next lecture, we're going to talk about the rate of reaction, which is how quickly a reaction occurs. So in order to increase the rate of reaction, more effective collisions must occur. So the more successful collisions we have, the more reactions can occur, the faster the reaction is going to occur.